In this video, we will demonstrate using Pothos to interact with an SDR device located on a remote host. The first step is to launch the Pothos proxy server on the remote host. First, we'll log into the host. We're going to run Pothos util. And we're going to specify proxy server. We're going to give it an empty string. The empty string means use default bind arguments. It will bind to all interfaces and use the default port. Now the server is running, a client can connect to the server and execute code and create arbitrary objects on the server now. Now that the server started, let's tell Pothos GUI about the remote host by creating an entry in the Host Explorer. Go to the Host Explorer panel. In this box, we'll find an entry for the URL of the remote host. Let's enter the one running the server. Click Enter. Okay. The new server should appear in the listing below, and if we click on it, we'll query information from this remote environment, and it'll be made available in the panel below. Here we can see OS, version, available processors, NUMA nodes. We'll also see that the OpenCL blocks installed have populated information about the GPUs available on the system. And if we keep scrolling down, we can see that the SDR processing IP has populated information about the available SDR devices. And we can see that an RTL SDR dongle is available on the system, and we'll be using that for the demo. In the Pothos GUI, affinity zones are places of execution for processing IP. We are going to create an affinity zone to represent the remote host. Go to the affinity panel. In here, we'll enter a name for a new affinity zone. Let's call it remote, and click Create. So we get a bunch of default options. The first thing to do is to choose the remote host. You'll notice that the available processors have appeared below. For the purposes of this demo, we're going to ignore these options. However, we will choose a color. This is a color that will be used to designate blocks sent to that affinity zone. Okay. Now let's design a simple spectrum viewing app for the remote RTL SDR dongle. Let's go over to the block tree. We're going to select the SDR source, drag it in. Now this block's been instantiated on this local host. So first we're going to send it over to the remote host by applying an affinity. We'll apply the remote affinity. You'll notice this block takes on the color we chose earlier. This is now executing on the remote host. Okay, now let's fill in the rest of the topology. These are our display and plotting widgets. We'll connect the stream source to them. Okay, and we're going to add a numeric entry widget for controlling the frequency. We'll connect numeric entries value changed to the set frequency slot on the SDR source. Okay. And we'll also connect the frequency change signal from the periodogram to the numeric entry. So when the user double clicks on a selected frequency, it will affect the frequency throughout the rest of the system. Same with the spectrogram. Set frequencies. Okay. Let's specify some of the parameters. First, we'll choose the RTL driver. This will avoid selecting some of the other devices on the system. We'll increase the sample rate, and we're going to choose higher gain. Okay. Now we'll select some frequencies that we're interested in. So. Okay, let's insert our graph widgets. Okay. And our slider. Now that the design is complete, we can activate the GUI. Click Activate, and we can see the data is now streaming from the remote host, and we're viewing it locally. So let's adjust the look of some of these widgets. Adjust the levels a bit. Just get that right in view there. Okay. So now you can see that when we adjust the slider, contents in the GUI is moving and tuning. And we can select a waveform, double click, and notice that the slider changes position as well. You can do it here, and we've retuned. The way the plotters know about the new frequency is that a stream label comes off of the SDR source every time there's a retune event and is propagated through the system. To get an idea about how this is working under the hood, let's take a look at the rendered view. The rendered view is a dot-generated image of the topology. Go to the Execute menu and select Show Rendered Graph View. In this view, we can see where the network blocks were inserted to convert flows that cross network boundaries. You will notice from this graph that the plotters are actually composed of a hierarchy of blocks, a snooper, and a graphical display. The snooper is responsible for consuming the incoming samples and forwarding only the samples used for display purposes. You will also notice that the snooper and display blocks have a network flow between them. The reason for this is that the snooper has been instantiated in the default local scratch process, while the display must be instantiated in the GUI process. You see, by default, blocks are instantiated in the scratch process to keep buggy implementations from crashing the GUI. And so the resulting behavior is that the framework must create a network flow between the snooper and display. As a side note, if this behavior is undesirable, any block can be moved into the GUI process in the same way we move the SDR source to the remote host. Given that explanation, what we really want is to move the snoopers into the same process as the SDR source. Let's close the rendered view to bring us back to the designer. Now select the plotters, right-click, and we'll set the affinity to be the remote for both plotters. Let's create the rendered graph view again. Now observe that the snoopers are directly fed by the SDR source. Now let's demonstrate how the system reacts to a network outage by forcefully killing and restarting the proxy server. Let's go to the proxy server, Control-C. You'll notice that there's errors. Every block is now reporting remote host down. We can go restart the server. You'll notice that the topology is inactive, however has recovered. We click Activate, and we're now running again.